Okay, so we are continuing with our notes for algebraic proof, and we just practiced using the properties of equality. And so now we're ready to start talking about the parts of a proof. So a proof is a logical argument. We talked about Abraham Lincoln was looking for that word demonstrate. He was looking for a logical argument because that's kind of what lawyers do, is they have logical arguments for why their person is guilty or innocent. It's a logical argument in which you make statements that are supported by a statement that is accepted as true. And so we're going to focus on what's called a two-column proof or a formal proof. This contains statements and reasons organized in two columns. In a two-column proof, each step is called a statement, and the properties are called reasons. So here's our statements on this side and reasons on this side. So basically this is like what happened or what's happening, and this is like why it happened. Okay, and so for today, this why it happened is going to be our properties of equality on the right-hand side of a proof. We might also get into some other, by the end of the lesson, some other postulates and theorems. But all of those guys, the postulates, the theorems, the properties of equality, they all go on the right-hand side of your proof. Again, this is the pink sheet. All the theorems, properties, and properties of equalities that are on your pink sheet. All right, so some other things about a proof. You're going to always have what's called a given and a conclusion. And let's just, for the sake of an example, we'll say given that Ms. Benton teaches geometry, and I'm just making up a silly example just for you to get the hang of things here. And that proves that her conclusion is Ms. Benton loves math. Okay, so something like, excuse me. All right, so Ms. Benton teaches geometry. That's our given statement. And your given statement always is your very first statement of your two-column proof. Ms. B teaches geometry. And your very first reason is always given. And then your very first statement, my mistake. Your very last statement is your conclusion down here. So we're trying to prove Ms. B loves math. Okay, and then along the way you're going to say, because Ms. Benton teaches geometry, she must like geometry. And then because she loves geometry, she must love math, and you're going to have some stuff fill in the middle. Your final conclusion is going to be another one of these properties of equality, a postulate or a theorem. It is not ever going to be a conclusion or a proof. So now that we kind of have the hang of that, let's go try our first algebraic proof. So our given statement right here it is. Same thing. They've already filled it in for us. 2/3 x plus 6 equals 14. Our prove statement is we're trying to prove that x equals 12, and they've already filled that one in for us down here as our last statement. They've already filled in that our very first reason is given. So all the no-brainer stuff that you don't really even have to think about, it's already done for us. Alright, so just like we practiced a minute ago, the idea is you're trying to go from the first line to the second line and figure out what happened. So take a look. from the first equation to the second, the 2/3 x is still there, the 6 is still there. The 14 has changed now to a 42 though. And there's this extra 3 out front. So looks like they maybe multiplied, is 14 times 3, 42. Looks like maybe they multiplied both sides of the equation by 3. And so anytime you multiply something times both sides of the equation, you're going to call that the multiplication property of equality. We're just going to write multiplication. Then, so notice this, there's kind of a lag behind on the right hand side. From line 1 to line 2, what happened goes on line 2. Okay, let's see, from line 2 to line 3, what happened? The 42 didn't change, but it looks like this 3 on the outside of the parentheses was distributed, so we're going to call that distributive. Then from line 3 to line 4, looks like they got rid of this 18. They subtracted 18 from both sides of the equation. So we're going to call that the subtraction property. And then lastly, they got rid of that 2, so they divided by 2. So that would be division property because they divided by 2 on both sides of the equation. So more or less, on the right hand side, you're just explaining what they did. And then here on the left, they're explaining or why or how they did it, and over here it's literally the algebra steps. So I've got a U-try here. Looks like the given, it's already filled in for us. We know that right here they write given and the prove is already filled in for us. We just have to explain how they got from line 1 to line 2, and that'll go here, and then how they got from 2 to 3, that'll go here, and how they got from 3 to 4. So take a second and pause the video and you try. Okay, so I said that looks like they distributed that 2 times x and 2 times 12 to get 2x minus 24. Then it looks like to get from line 2 to line 3, they added 24 to both sides. So I called that the addition property. And then lastly, they divided by 2 on both sides. So I called that division. I hope you got those 3 as well. Alright, so here we go. Let's try another one. This time, none of the reasons are filled in. Okay, so also notice that this is in a little different format up here. It's an if-then form. When they do that, the hypothesis, the if part of the statement is your given, and the then part of your statement, your conclusion, is obviously your conclusion. It's what you're trying to prove. So they've already filled in the prove and the given statement, but I need to write over here. My very first reason is always given. Then it looks like they distributed that 3 in the beginning, and that's a little tricky to see, but they said 3 times x is 3x, 3 times negative 5/3. So now we have 3x. It looks like they went ahead and canceled these 3's out, so I have minus 5 now. Then plus 5 is new. On the other hand side of the equal sign, I have equals 1 plus 5. Looks like they added 5 to both sides of the equation, so I'm going to say addition. Then looks like they canceled these out and combined those. So since they're combining like terms, I'm going to call that substitution. Then from line, what is that, line 4 to line 5, they're dividing both sides by 3. So I'm going to call that division. And lastly, they're just like canceling that out and dividing that out. They're cleaning that up. So anytime you're simplifying, you're combining like terms, we call that substitution. Excuse me. or simplifying it. And again, you don't have to write out what kind of substitution it is. I'm just doing that for your benefit since there are two different kinds of substitution. So now if you want to pause the video and pick up on the next video, or actually this is the end of this video, looks like there's several reasons and statements not filled in on this next one. So you try.